Hello, welcome to lesson 2 on the topic Permutation and Combination. If you remember, in lesson 1 we had looked at the basic introduction and the concept of combination. Now before we start looking at some examples of combination, let me share with you some rules that you will be using. Okay, some rules of combination. I'm sure all of us would have studied these rules earlier, but a quick revision will be very helpful. What are the rules? The first rule is NC0 is always equal to 1. That means whatever may be the number of things, if the intention is to select 0 things, there is only one way. So NC0 is 1. What is the second rule? NC1 is always equal to N. So, if I have to select one boy out of 5 different boys, there are 5 ways. If I have to select a sweet out of 10 different sweets, there are 10 ways, and so on. So, what is NC1? NC1 is always equal to N. Third, NCN is also equal to 1. That means if there are n things, now see how logical this is. If there are n things and I wish to select all of them, obviously there is only one way of doing so, because you are going to select all of them. So what is NCN? NCN is also equal to 1. Students, let me tell you, all these can be verified using the formula also in case you want. Say for example, if you want to verify how NCN can be 1, so what is NCN? It is n factorial upon 0 factorial into n minus n factorial. So n factorial upon n factorial into n minus n factorial. So what you will have? You will have n factorial upon n factorial into 0 factorial. So you will have n factorial upon n factorial, which is 1. So I'm just sharing with you that obviously you can verify all these, but how logical it is to understand that NCN will be equal to 1. There is a fourth rule that you must know. And what is that fourth rule? That fourth rule is a beautiful way of representing this. NCR is equal to NCN minus R. Alright? I repeat, NCR is equal to NCN minus R. Now, I would want to share with you the logic of why these two are equal. Why are we saying that NCR is same as NCN minus R? Let me give you an example. Suppose there are 15 players in the Indian cricket team and a very important match is to be played today. And obviously the captain has to select the team for today's match, which means a team of 11 players. Now the question is, which of the 11 players are going to play today's match? So how do you decide? What is the number of ways of doing so? The number of ways of doing so is 15C11. Alright, that means to answer this question, you have to find out the value of 15C11. Now, is calculating 15C11 going to be easy? Probably not. So what we are saying? We are saying that 15C11 is same as 15C15 minus 11, and therefore 15C11 is same as 15C4. Alright. Now, there are two ways to explain this. One, if you write down the formula for 15C11, you will get a value. If you write down the formula for 15C4, you will get a value. If you compare both, you will automatically come to know that they are both equal. But that is not our objective. Our objective is to understand what is the logic behind saying, that 15C11 is same as 15C4. Now let's come back to our interesting example. So the captain has this task of deciding or probably coming into a room where all the 15 players are seated, and he has to announce the team for today's match. Please listen carefully. He can do so in two ways. One, he can name the 11 players who are going to play today's match. Okay, he can name the 11 players who are going to play today's match, or alternately, he can give the names of the 4 players who are being rested for today's match. Alright, so what are we actually trying to present? What we are trying to present is the number of ways in which 11 things can be selected out of 15 is same as the number of ways of identifying those 4 things which are not going to get selected. Okay, so if 4 things are not going to get selected out of 15, automatically the remaining 11 will be selected. I hope I am making sense here, and therefore on that same logic, NCR will be equal to NCN minus R. Where is this going to help you? Let me give you an example. Suppose you are doing a question, and in doing that question you have to calculate 15C13. I am not going to be very comfortable in doing this. Possibly I'll take some time. So what is the best step? Next best step? The next best step is to say that 15C13 is same as 15C2. Now what is 15C2? 15C2 is 15 into 14 divided by 1 into 2. And suddenly that same calculation becomes easy to handle. So students, you must remember these 4 rules. We'll do a quick recap. NC0 is always 1. NC1 is always equal to the number of things, that is n. NCN is also 1. And NCR, you have understood by now using the logic, NCR is equal to NCN minus R. Right? That in essence is the concept of the first part of permutation combination, what we all know as combination. Now, let us see how these concepts will get translated into questions. So, let me take up the first example for all of us. Alright, let me take the first example. A team of 11 players is to be selected. A team of 11 players is to be selected out of 6 batsmen, 7 bowlers and 2 wicket keepers. A team of 11 players is to be selected out of 6 batsmen, 7 bowlers and 2 wicket keepers. Alright. So you can take various situations. The first situation is, what is the number of ways in which the team can be selected? What is the number of ways in which the team can be selected? Okay. Now what is the first question? Does the first question have any condition? No. A team has to be selected. How many people? 11 people. How many available? 15 available. So what is the answer to the first question? The answer to the first question is 15C11. What is 15C11? 15C11 is same as 15C4. Right? And what is 15C4? It is 15 into 14 into 13 into 12 divided by 1 into 2 into 3 into 4. So 3 into 4 will cancel 12. 2 7 times is 14. So the answer is 15 into 91. Whatever that value would be, you can calculate. Okay. So a fairly straight and simple question. Now let us take another part. The second part is we are saying exactly 5 batsmen. Okay. Now children, sometimes what we do is when we are given this condition exactly 5 batsmen, please appreciate you are talking about 5 batsmen, but only selecting 5 batsmen will not serve the purpose. Right? Because please remember The task is to select a team of 11 players. It is not to select 5 batsmen. It is a condition that the team should have exactly 5 batsmen. Alright. So what do? You can translate this into the exact condition. So we are saying 5 batsmen and 6 others. Who can be the 6 others? They can be either bowlers or wicket keepers, we don't know. They can be any player except batsmen. So 5 batsmen and 6 others. How will we do this? So you have to select 5 batsmen out of 6 batsmen. This is nothing but 6C5. Okay, 6C5. So 5 batsmen out of 6 batsmen. What do you have here? You have and. What will and actually mean? Multiply. 6 others. 6 others. Out of how many people? 7 bowlers and 2 wicket keepers. So out of 9 people you have to select the remaining 6. Sometimes students will make a mistake of including this batsman also here. And they'll say 6 others out of 10 people. That's wrong. You cannot include the batsman who has been left out. Please remember that. So 6 others will be 9C6. What is 6C5? 6C5 is same as 6C1. What is 9C6? 9C6 is same as 9C3. So 6 into, this is 9 into 8 into 7 divided by 1 into 2 into 3. So 3 times 9 and 2 4 times 8. So the answer is 6 into, this will be 6 into 84. So this is 480 plus another 24. That means this is the total number of ways is 504. Alright. So what I am actually trying to share with and tell all of you is, in any question of permutation combination, if I am logically clear, if I am logical, right, I don't worry too much about the formula. If I am logically clear, conceptually clear, then I should not have a problem in handling the questions. I hope this has clarified some of our doubts with reference to the application of combination. Thank you.